Our first lesson for the fractions unit would be to find factors. So that's what we're going to be working with today. Factors are very important and very useful for us when we start working with fractions. So in order to become better at using fractions, we are going to work on finding some factors today. I've got a few vocabulary terms for you. The first one would be factors, and that's any two numbers that you multiply together. So for example, 3 and 6. I know I can take 3 and 6, multiply them together, and 6 times 3 is 18. I know I can take 5 and 4. If I multiply 5 times 4, I get 20. So I just basically just think of any two numbers I multiply together, those are factors. Now, what if we're looking for a specific number? Well, then we're looking for a particular factor pair. And those are two numbers that can be multiplied together to get a particular number. So for example, if I'm thinking of the number 20, I know that I can take 1 times 20, I can take 2 times 10, or I can take 4 times 5. Now, I'm not just thinking of any random numbers in that situation. I'm thinking of two numbers together that get me that specific number of 20. So in the first part, when we have just any factors, there are any old numbers you multiply together. But the factor pair is when we're looking for a particular answer. Once we understand the factor pairs, that's going to help us with understanding prime factorization. Um, when we have prime factorization, it's the number written as a product of prime factors. Now, there's a lot of words in there we kind of want to talk about. The first thing is it's a product. We know the product is the answer to a multiplication problem, so we're going to be writing this down as a multiplication problem. The word prime in there tells me that I'm going to be using prime numbers, which is what we looked at when we looked at the sieve of Eratosthenes the other day. So we're going to be using that to help us as well. One of the really nice things about doing prime factorization is that we can use a factor tree, which is a visual aid that helps us to find the prime factorization. So it sounds like it's a difficult process, but really it's very simple, and the factor tree makes it very, very easy for us to see. So let's go ahead and get started. The first thing I want to do today is just list some examples of some factors of 30. So if I start thinking to myself, I just say, okay, what are some things that I know that I can multiply a number by to get 30? Well, I know that 2 will work. It's an even number. It ends in a 0, so I know it's divisible by 10. Ooh, and 5 will work also, because we know that based on our divisibility rules that 5 works for any number that ends in 0. As I think some more, I'm starting to think, oh, I know 6 will work because I know that 6 times 5 is 30. 3 is going to work because our divisibility rule says 3 plus 0. If we add those digits together, that number is divisible. 15 is going to work. And then the most obvious ones are 1 and 30. So there's a list of my factors of 30. 2, 10, 5, 6, 3, 15, 1, 30. Now I've got kind of a problem with that, and that's the fact that it just doesn't look right to me. It's kind of a jumbled mess. I just don't care for the way it looks. So what I'm going to do is I'm going to try to make it in a more organized way, and I'm going to write these down in order. And there's a trick to it. Every single number that we multiply is always, always, always going to be divisible by 1. 1 will always be a factor of every number. You can always take 1 times itself, times the number itself to get that number. So I know that 1 is always going to be a factor. Now here's how I'm going to do it to make a nice organized list. And I'm going to do this so I don't have to write it out first, because I could always write these factors out and then just write them now in numerical order: 1, 2, 3, 5, 6, 10, 15, 30. But to me, that's a wasted step to write them out like that. So I'm going to write the factors out as I think of them. So 1, I know that 1 times 30 gives me 30. So I'm going to come over here a little ways, put some space in between, and put a 30. I'm going to think about 2. I know that 2 can work because 2 times 15 is 30, so I'm going to put 15 over here. And I just work my way into the middle. I know that 3 works because I know 3 times 10. 4 won't work, and we talked about our divisibility rules, and I know that if I take 30 and divide it by 2 the first time, I get 15. But I can't divide it by 2 a second time. So when I can't divide by 2 twice, because it's an odd number when I divide it the first time, 4 is not going to work for me. But 5 I know does, because 5 times 6 is 30. And so there, now I've written down the list of factors of 30 numerically in order from least to greatest, and I don't have to waste the step like I did up here of writing the number out and then turning around and reorganizing them. So it's as simple as that. Let's try this with another number. For example, 24 is one we can start with. So I obviously know factors are always going to be 1 in the same number, so I'm going to write down my 1 and my 24. I'm going to think about 2. Is 2 a factor? Well, 24 we said is an even number, and any even number can be divisible by 2. So 2 is going to work, and if I think about it, I know that 2 times 12 is 24. Let's think about if 3 would work. Remember, threes are the numbers divisible by 3's if we can add the 2 digits together or the digits together, and then that number is divisible by 3. 2 plus 4 is 6, so yes, 3 is going to work, and I know that 8 times 3 is 24. Will 4 work in this case? If 24 is divided by 2, that gives me 12. Can I divide that again? Yeah, then it's 6. So 6 times 4 is 24. And there's my list. 5 doesn't work because it doesn't end in a 0 or a 5. And at that point, I'm starting to go back up the side that I already started with. So there's my list of factors. You give it a shot. Pause the video, write out the factors of 18, and hit play to see how you did. Okay, let's take a look here. Hopefully you start off with 1 and 18. Now, if doing this method where you work your cells from the outside in, from the most basic of 1 and 18 to the middle, if that's still a little bit of a struggle for you, don't worry about still writing them out like I did at the very beginning, where you just write them out as you think of them and then reorganize them. That's fine, whatever works. But this is just a way to help you save some steps. Hopefully you also remembered then that if you got 18, an even number, you know you can divide by 2, and you know that 2 times 9 is 18. If you take 1 plus 8, that's 9. 9 is divisible by 3, so 3 definitely works there. 3 and 6. 4 won't work because if we divide by 2, 18 divided by 2 is 9. We can't divide 9 by 2 evenly with a whole number again, so 4 doesn't work. 5, the number does not end in a 0 or 5, so that won't work. And there's our 6. We're starting back down this path again. So there's your list. Here are your factor pairs. You've got 1 and 18, 2 and 9, 3 and 6. Hopefully you did all right on those. If you have any questions on that, you can always come in and see me, but it's just as simple as listing down what you can multiply together to get 18. Now that we understand how to make a list of factors, now I want to be able to do prime factorization. And I'm going to do the number 30 again because that seemed to work out well for us. And remember our factors of 30. We just said that 1, 2, 3, 5, 6, 10, 15, and 30 are all factors of 30. But when we do prime factorization, we're looking for prime numbers. So the numbers we have here that are prime are 2, 3, and 5. 1, 6, 10, 15, and 30 are not prime numbers in this situation. So we're going to have to do a little bit of work. Here's how we do a factor tree, and it's pretty simple. The basics of a tree are you have the trunk that grows up, and then it branches out into some large branches. And then those branches branch into the smaller ones, and then at the end of those small branches we have leaves. Well, the tree is almost sort of upside down. In this case, we're going to put our trunk at the top, which is 30, and then we're going to branch out from there. If I'm doing prime factorization, I'm looking for factors that make 30. Now, a lot of times we might want to start off and say, oh, I know, I could do 1 times 30. That's going to get me 30. And while that'll work, unfortunately what that does is that just basically makes another step for us because 1's not a prime number. That's not going to help us in this situation. And 30's here, now 30's here. All we're doing is adding another step that we don't need to add. So what we can do instead of doing 1 and 30 is any other factor besides 1 and 30. So now if I'm going to take my 30, I'm going to go back and look at my set, and I'm going to say, you know what? Let's try 3 and 10. So if I take and I make my branch of 3 and 10, it looks like that. Okay. Now remember, we're looking for prime numbers. So take a look at your first branch, first set of branches there, 3 and 10. Do we have a prime number? Yes, we've got a prime number of 3. So I'm going to go ahead and just circle it because I know that I'm done. I've found my prime number there. But 10 is not a prime number. So let's think of 2 factors that can go together to make 10. Again, let's avoid 1 and 10 because that just doesn't really help us very much. You're probably thinking to yourself, we can do 2 times 5. Well, is 2 a prime number? Yes, it is. Is 5 a prime number? Yes. So now we are done. We've completed our tree because we are all the way down to where all we have left are prime numbers. Now remember, the definition of prime factorization is to write the number as a product. So it's the answer of a multiplication problem. We've got these three numbers here, 2, 3, and 5. Let's see if we multiply them together if we end up with the number 30. 2 times 3 is 6, and 6 times 5 is 30. So we've got it. We've got our prime numbers there, and they all multiply together to get 30. Now you could definitely switch these around. Like if you would have wrote them down 3 times 2 times 5, you're going to get the same answer. 3 times 2 is 6, 6 times 5 is 30. If you wrote it down as 5 times 3 is 15, 15 times 2 is 30, that works. Any way that you write them down works. But for me, I like to write them down from least to greatest because that's going to help us in the long run as we move on towards finding least common multiple and greatest common factor. So I would just make sure that you write your prime numbers as from least to greatest. Now, if you're looking at this, you might say, well, wait a minute. What about there's other factors here? There's other things other than 3 and 10. What if I chose 5 and 6 to start with? Well, let's go back and let's try another factor tree, but starting with 5 and 6. If my first branches are 5 and 6, is 5 a prime number? Yes. So we're going to circle it. We're done with that one. Let's look here. That's not a prime number. I know that I can still factor that out to 2 times 3. And look what I have. Prime number here, prime number here. I still have my 2 times 3 times 5. So there's no perfect way to do a factor tree. You can do it multiple ways. I could also choose to do it with 2 and 15. Any way you want to do it, the end result is going to be the same. You should start with the same number and end with the same numbers, but however you do it, yours is going to look different than somebody else who works on this, and that's okay. However you want to do it makes it easy for you. Let's try another number. Let's try 24. Again, as a refresher, here are the factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. So for this one, I'm going to go ahead and start with, let's say, 3 and 8. That'll be my first start. I'll start with 3 and 8. Change colors here. But let's start with 3 and 8. So I make my first branch. 3 times 8 is 24. 3 is a prime number, so I'm done there. I can circle that. 8 is not. So I think of my factors of 2 and 4. 2 times 4 is 8. 2 is a prime number, so I'm done there. 4 is not. I can factor that out to 2 times 2. And now I have a prime number here, prime number there, and I'm done. You're done when you can't break down these numbers anymore. If I write this out, it should be 2 times 2 times 2 times 3. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. Again, we can do this a different way. I can still start with my 24. And let's say this time, instead of doing 8 and 3, I want to do 4 and 6. 4 times 6 is 24. 4 is not a prime number, so I have to split that up. And I know that I can factor that out as 2 times 2. Those are both prime numbers now. 6 can be factored out as 2 times 3. And there you go. 2 times 2 times 2 times 3 gives me 24. Again, no one way you have to do this, but as long as you start with the same number and end with the same numbers, you've got it. All right, your turn. Try to do the prime factorization of 18. You can look back in the video or look back on your notes of the factors to start with, but go ahead and make your factor tree. Hit pause, see what it looks like, and check your answer by hitting play. All right, you should have started with 18 as your top number. There's a couple different ways you could go. All right. You could have gone 2 and 9. And if you did that, you found that 2 is a prime number. 9 is not. 9 can be factored as 3 times 3. which are both prime numbers. So you end up with 2 times 3 times 3, and that is 18. 2 times 3 is 6, 6 times 3 is 18. You might have also started it as 18. Sorry, my writing's getting a little sloppy here. You might have also said 3 times 6. This is a prime number. 6 can be factored into 2 times 3, which are both prime numbers. And you still ended up with your 2 times 3 times 3. Also, you could have done, oh, I shouldn't say you could have done, but you wouldn't want to do 1 times 18. If you did, you're going to get the same result, but it's just going to include an extra step. Remember, if you have any questions on any of this stuff, please stop in and see me either before school, during lunch, or after school. Get some help if you need to. Make sure you keep that list of prime numbers handy because, as you can see, we're going to be working a lot with them. Hope you learned something, and good luck on your homework.